Hello, everyone. Hello, and welcome to our second webinar as part of the Technical Webinar Series 2021. If you want to ask questions, please use the Q&A button at the right of the webinar at the GoToWebinar tool, and you can share with us every question you might have during the presentation. Sergio will cover as many questions as possible at the end of the presentation. This webinar will be recorded, and access to the recording will be distributed to attendees after the session. With over 35 years with domestic and international experience, i-Gard's full line of neutral grounding resistors, ground fault protection systems, and power resistor-based solutions provides world-class power protection. Today's webinar is entitled Absence of Voltage Tester, a safer and quicker way to establish an electrically safe work condition. Sergio Panetta is the Vice President of Engineering at i-Gard Corporation. He will be the host during today's webinar. He is a graduate of McMaster University with over 3 decades of electrical engineering experience in switchgear design, commissioning, and troubleshooting in power system protection and power system grounding. Sergio is a senior member of the IEEE, member of the IET, and has been awarded consulting engineering status with the PEO professional body. Sergio is the author and owner of several US patents related to electrical safety. Please join us to welcome Sergio Panetta.
Thank you, Miriam. This particular technical webinar is a little bit of a departure from our normal grounding series but it's involved in safety, and we're branching out into more safety-related products. So with that in mind, what we've noticed is that over the past 10 years, people are getting injured and fatally wounded as far as electrical safety is concerned. As you can see, from 2011 to current, there's been a steady trend of electrical fatalities in the electrical workplace, and electrical injuries has more or less stayed steady or gone down a little bit. So we've seemed to have focused a lot in the industry on arc flash and not really touched upon electrical safety as far as contact is concerned. So a lot more people are getting hurt by electrocution and contact with electrical components than with arc flash. So despite awareness campaigns, this month in Canada has been Electrical Safety Month. So we've had 12 electrical safety months over the past 12 years, and it doesn't seem to be doing any good. So something needs to change, and something needs to be different. So if we look at NFPA 70E, and this deliberately is a 2018 version of 70E. So establishing and verifying an electrically safe work condition. Obviously, we have to determine all possible sources and with our electrical supply and specify equipment and ensure that all our drawings are up to date. And so our electricians know what they have to shut off in order to establish a de-energized workplace. But just because you shut everything off doesn't mean you have a safe condition yet. Check all the disconnects devices, make sure all the blades are open, release stored energy, block or relieve stored non-electrical energy from devices to make sure there's no reclosures, apply the lockout, tag out, and And number 7 is use of an adequately rated portable test instrument to test each phase conductor or circuit for the absence of voltage. We know we can test for the presence of voltage, but we're testing for the absence of voltage before we can actually test anything and touch anything and perform our work for that particular function. We go through our job briefings and we know what we have to do, but in order for us, before we could start doing these job tasks, we have to ensure that it is safe to continue work. So traditional approach to test before touch is to consider all circuits are energized until they are tested and verified that they are de-energized. Test every conductor that needs to be touched. PPE is required until the test is complete. Test instruments must be verified. Obviously, you have to ensure that your test equipment is working properly to verify that the meter is working, to verify the absence of voltage. Knowledge of the equipment is essential. Test the circuit again if job continuity is broken. I've been to many electrical safety workshops, and it's astonishing to me how many times people run into difficulty, and even if they just need to go and get another tool and come back, they should always re-verify that the gear is de-energized before going in. Countless number of accidents and fatalities have occurred because people have gotten into the wrong cell. And so this is very important. And this becomes part of awareness. Testing must be done at each location where conductors are going to be touched. So what we have to do is we have to arrange the barriers around the equipment to be tested, de-energize the electrical equipment, apply locks and lockout tag out as per the instructions, select and inspect the PPE. So even before we put on the PPE, we're working outside the cell. We don't really require the amount of PPE because we're working on the doors closed, we're operating on gear which is supposedly functioning properly and no impending signs of a fault. We don't necessarily need to put on the PPE. Select the appropriate tester and test the appropriate tester. Now we open the door. Test the phase to phase and phase to ground, retest the tester on an unknown source. Now we've established an electrical work area. So what we find is after we put on the PPE, this is when most people get hurt. After the PPE is put on, 18.3% of facilities experience personal injury when using handheld voltage test instruments. 36.7% reported near misses or injury. 11.7% of facilities experience interruption and planned operations due to voltage test incidences. This is after we put on the PPE. So something is definitely wrong if we're continuing to do this. The trends indicate that we're not helping more people go home at night. So we need a different approach. Now we've entered into the 2018 version of the electrical safety 70E says we have to use a permanently mounted test device. It is permanently mounted and installed in accordance with the manufacturer's instructions and test conditions, conductors. It is listed and labeled for the purpose of the absence of voltage. It tests each phase to ground and phase to phase, and the test is verified with a known voltage source. These equipments are permanently mounted test devices and they're voltage indicators, but they're presence of voltage indicators and not absence of voltage indicators. These lights come on when voltage is present. These lights are not on when the voltage is not present. They are typically illuminate between 40 and 1,000 volts, depending on the manufacturer. Voltage indicators should never be verified used to verify the absence of voltage because they do not work if the voltage is less than 40 volts. So if a light bulb is out, that doesn't necessarily mean it is de-energized. Lack of illumination can be caused by a failed LED, bad installation, or a failed device. Installation codes often require voltage indicators to be fused, so the fuse can be blown. And if the fuse is blown, you're not going to get any indication on the LEDs. So to compensate for the voltage detector LEDs, we put in test portals. Test portals are permanently mounted devices that can be used with the portable tester, such as a digital multimeter, to measure voltage. These devices are excellent tools for troubleshooting. If you want to do face-to-face testing and face-to-ground testing, they can be used for that. However, they should not be used for absence of voltage testing, because the only thing that you can verify by testing one of these devices for the absence of voltage is that there's no voltage present at these terminals. We haven't really deemed the gear to be de-energized. So there was a promoted practice of using combination voltage indicators and voltage test portals for conducting the absence of voltage tests. You can see by this graphic. The voltage is present, the lights are on. Open the disconnect, select the adequately rated instrument, verify the meter to know its presence, verify the absence of voltage by testing face-to-face and face-to-ground, verify the meter to be working. And it says here, if you measure no voltage, you have an absence of voltage. All we've really done is establish that this device does not have voltage on it. There are still wires connecting this device to the back, and it reduces the time it takes to test the absence of voltage to 50%. However, we've shown that it cannot be relied upon because we're still finding a lot of people getting hurt and a lot of people are dying because of traditional practices that we have been using in the past. These numbers have not changed. 2018 is when the NFPA 70E 2018 came out, and we're still not helping people go home at night. 417 of these deaths were caused direct exposure to electricity, such as touching a live wire. Again, we reiterate, a lot of the testing, a lot of the injuries are occurring after we put on the PPE and we're performing the absence of voltage test. We saw this from the graphic we had earlier. The leading location for fatal injuries from direct exposure is industrial places and premises, 36% of deaths. People are getting hurt. Traditional methods that we've used in the past are not good enough anymore. Hence, NFPA 70E 2021. They put an exception over here for which the note 7 is the same, but an exception to note 7 is an adequately rated permanently mounted absence of voltage tester shall be permitted to be used to test for the absence of voltage. Listed and labeled, but they went on further and said it must be listed and labeled to UL 1436. CSA Z46221, basically the same thing. And we've added more notes over here. Design requirements for permanently mounted absence of voltage testers refer to UL 1436. Still has a meter, so you have to test to CSA and UL 61010, but for specific reasons, 1436 is a standard that all absence of voltage testers must abide by. The i-Gard absence of voltage tester is listed and labeled for the purpose of verifying the absence of voltage. to 1436, UL 1436. The standard in section 7, a permanently mounted absence of voltage tester is to verify the circuit is de-energized prior to opening the electrical enclosure that contains energized electrical conductors or circuit paths. An absence of voltage tester is provided with test circuit with active indication to verify the absence of phase-to-phase and phase-to-ground voltage. So here's a device that you can test before you open up any doors and before you apply any test probes into the cell where most people were getting hurt, that can verify the absence of voltage. And it looks like this. The i-Gard absence of voltage tester has a control unit, wire, 2 per phase and 2 for ground. So we have to put in 2 wires per phase and ground to verify that the actual unit is connected. The wires are physically connected to the point of contact that you're testing. If one of the wires was to come off, you would fail the continuity test and the test is not valid. And the only thing you see on the front is a display unit. It has a blue ready light, 3 LEDs that are red or green, and 2 amber LEDs and a test button, push button. This is the only thing you see on the front panel. It could be on a mullion, it could be on the door, and it's connected with a Cat5 cable, so you have low voltage coming to the door. There's not 600 volts or 480 volts coming to the door, there's 5 volts coming to the door. So this product is internally fused at 500 milliamps. The control unit has 2 boards, top and bottom board. Power is derived from the bus, so no additional power supply is necessary for this unit to be working. We have 1 unit that works from 120 volts to 690 volts. However, it's only UL listed and CSA approved to 600 volts. But it works on 690 volts. The secondary source is charged from a supercapacitor right here. So we charge the supercapacitor, and this is our secondary source that we use to verify the absence of voltage and test our meter to a known device or known voltage. And a Cat5 cable connects the display unit to, I don't know if you can see it, but that part of the control unit. So there are 2 sensor leads connected every phase, 2 phases on A, 2 wires on A, 2 wires on B, 2 wires on C, 2 wires to ground. And this is to verify that it's properly connected, and this is a requirement of UL 1436. I didn't put the wires in there, i-Gard didn't put the wires in there because it's more cumbersome. We have to put the wires in there to comply with 1436. So the operation is quite simple. The blue light comes on when the capacitor is fully charged and ready to conduct the test. The 3 red LEDs are on to indicate that there is a presence of voltage on the bus. We don't know what that voltage is. Well, all we know is it's more than 3 volts, but there's a voltage present on the bus. Because this 1 unit can verify the absence of voltage on circuits 120 volts to 690 volts, all we're telling you is that there is greater than a lethal voltage present on the bus. 3 green LEDs means there is an absence of voltage on the bus, which means it is safe to enter and contact and perform work on the area that this device is connected to. The blinking amber or yellow lights indicate that it is undergoing a test. The test is in progress, and we'll get more to the test later. It takes about 20 minutes to charge the supercapacitor. Contrary to some of the other devices that are out there, they use batteries. We use a capacitor. You get about 10 tests per charge, and the charge can remain for up to 15 hours. So the new method now of rendering a gear safe, or verifying the absence of voltage and having an electrical safe workplace, is to de-energize the equipment using the normal method that you had before. You still need that up-to-date single line. Apply the lockout tagout, press the test button on the display unit, and then if you get 3 green LEDs, it's safe to open that door. We've gone from a 20-minute procedure to a 20-second procedure. So this is what happens. Step 1. The supervisory circuit verifies that the phase to voltage lights are off. Those 3 red LEDs are de-energized. Supervisory circuit verifies that the sensor leads are connected. So we perform a test to make sure that A phase, B phase, C phase, and the ground conductor are connected to where they're supposed to be connected. So we verified that the system is connected properly and there's no voltage present on the bus. Step 2. Verify that the energy level on the bus is low enough to perform the test, and verify that the voltage source is sufficient to perform the test. This is testing the capacitor to ensure that we have enough energy to perform another test. Step 3. Verify that the voltage A to ground, B to ground, and C to ground is below 3 volts AC, and A to B, B to C, C to A is less than 3 volts AC. Step 4, verify that the voltage A to ground and B to ground, C to ground is less than 3 volts DC, A to B, B to C, and C to A is less than 3 volts DC. Step 5, verify that A phase, B phase, and C phase are still connected the way they should be. Step 6, repeat the AC test. Phase to phase, phase to ground. Step 7, repeat the DC check. Step 5, repeat the continuity check. So we've checked the voltage phase to phase and phase to ground twice. We've checked the continuity of the circuit twice. And in real time, the way it happens is we go through all these procedures in 10 to 15 seconds and ensure that everything is less than 3 volts AC, DC twice. We check the continuity twice, and when that's done, you get 3 green LEDs, and you verify that the voltage is truly absent from that circuit. And we've checked the circuit to make sure that it's connected properly. We've checked the instrument to make sure it's functioning properly. And so you have a electrically safe work condition. So all the verifications are done in a sequence. It takes less time, much less time than it used to do before. 20 seconds, it's done. Only when all verification tests have passed, the 3 green LEDs illuminate. It takes about 10 seconds I said 20 seconds because it probably takes you about 5 seconds to find the button. So 3 green LEDs, sorry, 3 red LEDs, it's unsafe. Do not open the door. Or only qualified people should open the door and perform what testing they need to be done. But you have to wear proper PPE at that point in time. If you have 2 flashing green lights, or sorry, amber lights, the test is in progress after you've pressed the test button. 3 green LEDs, it's safe to open the door and it's de-energized where it's connected. And we verified that the connection is good. So section 12 of UL 1436, there are specific construction and operation clauses that relate solely to the absence of voltage tester. An absence of voltage shall be provided with the means for the user to initiate the test. We have a test button there. Shall provide the user with the visual indication to confirm that the absence of voltage after the absence of voltage test has been performed. So we have the 3 green blinking lights, and after the test is performed successfully, you have 3 green LED lights. The absence of voltage tester shall incorporate a supervisory test circuit to verify that the tester is functioning properly. This is done internally. It's testing itself after you've pressed the test button to ensure that it's properly connected, all circuitry is functional in order to come up with the green LED. So you have to satisfy that the tester is working properly, it's connected properly, and you have less than 3 volts. The absence of voltage testers supervisory circuit is incorporated a secondary power source. We have a supercapacitor, which is our secondary power source. So we have to test these tester to a known power source, and our known power source is the capacitor. The absence of voltage indicator shall only illuminate green when all phase-to-phase and phase-to-ground are less than 3 volts AC or 3 volts DC, depending on whether it's AC or DC, and we do that. The absence of voltage visual indicator shall not illuminate green unless the phase-to-ground leads are directly in contact with the circuit conductors being tested. This is done through the continuity test, and we perform that test twice with the i-Gard absence of voltage tester. The absence of voltage visual indicator shall not illuminate green if all phases and connected to ground and ground leads shall be connected to the phase conductors. Okay, so if you swap the ground and the phase conductors, it's not going to illuminate green. The absence of voltage shall comply with standard of functional safety IEC 61508 and achieve SIL3 rating. SIL3 is safety intrinsic level. A permanently mounted, so the requirements of 1436 in comparison to some of the products that are out there and some of the products that I've shown here, they're i-Gard, Panduit, and I think there's Grace Technology, and I think there's another one out there too. So a permanently mounted test device that is used to verify the circuit is de-energized. The i-Gard, i-AVT, the Failsafe, and the Grace product does this. According to 1436, 12.1.2, an absence of voltage tester shall be provided with the means for the user to initiate a test. The i-Gard, i-AVT has this functionality. The Panduit Failsafe has this functionality. The Grace Technologies does not have this functionality. 12.1.3, the absence of voltage tester shall provide the user with a visual indication to confirm the absence of voltage after the absence of voltage test has been performed. Again, i-Gard i-AVT does have this function. The Failsafe does. The Grace product does not. 12.1.5, the absence of voltage tester shall incorporate a supervisory circuit. Again, i-Gard, i-AVT, yes. Failsafe, yes. Grace, no. The absence of voltage tester supervisory circuit has incorporated a secondary power source. We use a supercapacitor, Panduit uses a battery. Grace does not comply. The absence of voltage visual indicator shall only illuminate green when all three phases, phase to phase and phase to ground, are less than 3 volts AC or 3 volts DC. The i-Gard, i-AVT complies. Failsafe by Panduit complies. The Grace product does not comply. 12.1.7, the absence of voltage tester visual indication shall not illuminate green unless the phase to ground leads in direct contact. Okay, so it's connected properly, yes. The i-Gard, i-AVT performs this continuity test. The Panduit Failsafe performs this continuity test. The Grace product does not comply. 12.1.8, the absence of voltage visual indicator shall not illuminate green if all phase indicators connected to ground and ground leads are connected to a phase. Yes for the i-Gard, i-AVT. Yes for the Failsafe. The Grace product does not comply. 12.19, so good, you have to mention it twice. The visual indicator shall not illuminate green unless the secondary power source is operational. Yes for the i-Gard, i-AVT. Yes for the Panduit Failsafe. No, the Grace does not comply. 12.2.1, the AVT shall comply with the standard for functional safety 61508 to achieve SIL3 rating. The i-Gard, i-AVT, yes, the product does comply with SIL3. Panduit, Failsafe, yes, the product does comply with SIL3. The Grace technology does not comply. So exception number 1 to 7, an adequately rated permanently mounted absence of voltage tester shall be permitted to be used to test the absence of voltage. So permanently mounted, yes, all these devices are permanently mounted. The test the conductors and circuit parts to the point of work. The Grace product does not comply with note exception number 1 to 7. The portal does not comply because you have to use a separate test instrument. The Failsafe and the i-Gard, i-AVT both comply. It is listed and labeled for the purpose of testing the absence of voltage. No to the Grace products, yes to the Failsafe, and yes to the i-Gard, i-AVT. Test each phase conductor phase to phase and phase to ground. Only phase to phase or phase to ground is tested with this product, the lights. With the portal, you can test phase to phase and phase to ground. And the Panduit Failsafe and i-Gard, i-AVT both comply with testing phase to phase and phase to ground. The test device is functional and tested and verified as functional. No to the lights. No to the combination lights and portal from the Grace product. The Panduit and i-Gard, i-AVT both comply with this. Meets rating design requirements for absence of voltage as described by 1436, UL 1436. The Grace products, no, yes to Panduit, and yes to i-Gard. The i-Gard, i-AVT allows the absence of voltage tester to be initiated via the press of a button that completes a test in 10 seconds and allows the test to be conducted prior to opening electrical enclosures, thereby reducing the risk. This is the new technology that we want to use moving forward to ensure less people get hurt, less people get killed. A mind shift has to take place for people to go home and perform their work under safer conditions. What we've done in the past has been proven not to function properly. People are getting hurt, so a mind shift has to occur, and Z462 in the 2021 version and NFPA 70E in the 2021 version understand that, and they've had to implement more safety related products suitable for the use of verifying the absence of voltage to remove people from harm's way when they're conducting the absence of voltage test the historical way. So we only get 3 green LEDs once we verify that the phase to phase and phase to ground is less than 3 volts, AC and DC. We ensure that the continuity of the device is tested and operating properly as per manufacturer's recommendations, because we actually do that test twice on the device before the green LEDs come on. It is maintenance free without a secondary power source, or the power source is built into the unit and is deemed maintenance free because it's a supercapacitor and has a lifespan far greater than that of a battery. The absence of voltage tester, the i-Gard i-AVT, is SIL3 rated, ensuring that it will not provide false positives. And we've spoken a lot about SIL3, so what does that mean exactly? And believe me, this is not an easy test to pass. The 61508 defines SIL using requirements grouped into 2 broad categories: hardware and firmware. The i-AVT is a type B element with hardware fault tolerance of 0, and so it must have a safe failure fraction of greater than 99% in order to have SIL3 rating. There are 4 levels of SIL according to 61508. SIL1, SIL2, SIL3, and SIL4. SIL4 is the most stringent of the safety intrinsic levels. For a product to be tested and listed under UL as a absence of voltage tester, you must achieve SIL3, which basically means you're going to have a product which is truly functional and almost guaranteed not to fail in a long time, because this is the type of testing that has to be done on this product. And it took i-Gard a long time to achieve this SIL3 rating because of all the stipulations that had to ensure that the product was not going to fail. And more importantly, if it does fail, it will not fail with an indication of 3 green LEDs, because that will put people in harm's way. So your process to establish electrical safe work condition involves wearing PPE and opening cabinet doors to measure voltages. And again, we've seen that this is when people get hurt, because this is when they're exposed to the hazard. They have a restricted approach boundary, but they're still getting hurt, still dying from testing the safe condition that they should have. If your process is to establish an electrical safe work condition, you have to use multimeters and calibrate for the task. We're not going to use a 600 volt test instrument to test 5 kV. So you have to select the appropriate test equipment to perform the test. But we've cut down establishing a safe workplace to 10 seconds. And up until this point, you haven't not to wear any PPE, and you can do all this with the door closed. So before you put on any PPE, you can actually verify that the voltage is absent with UL 1436 and SIL3 and the i-Gard i-AVT. So installing the i-Gard i-AVT will cut your process of establishing a safe workplace by 20 minutes. But more importantly, it helps you save lives because, as we saw earlier, most people get hurt or injured, killed, establishing a workplace safe condition. And so we'll eliminate that hazard. So if you need to conduct an absence of voltage test, you choose a product listed and labeled for the purpose. And you can see here, it conforms to UL standard 1436. It's also certified to CSA standard C22, but the UL 1436 is the most stringent standard for the absence of voltage tester. If you still want to use a voltage portal, we have a product that we're launching in the near future, which will combine the LED lights as well as the portal in one combined unit, as well as using non-contact testers. So this device will use all three. However, it is not an absence of voltage indicator. It is a voltage test indicator and portal. And with that, just a prelude to next month, we're going to have transformer protection using surge suppressors, how i-Gard differentiates. And with that, I'd like to turn it over back to Miriam with any questions, and thank you for your time.
Thanks, Sergio. Thanks for your presentation today. And yes, we have several questions here. Okay, so let's go with the first one. Okay, the first one is, can the i-Gard absence of voltage tester be used on Delta or HRG systems to indicate a faulted grounded phase?
Good question. And this one hurts me the most. We had that ability when we first started to test the, when we were going to market this, we were going to market it as a product that can actually tell you which phase is faulted by having the red LED flash indicating that you had a ground fault on a Delta or HRG system. However, that was a function that had to be removed to meet the SIL3 rating. So yes, it had it. No, it doesn't anymore. But because we had to remove that functionality to achieve SIL3. So it'll work, but it does not indicate a voltage alarm. If that's important to you, we have other products that do that same function.
Okay, the next one is, how does the control unit get mounted?
We have a couple of different mounting procedures right now. We're looking at modifying it somewhat so that it can fit on a standard DIN rail, or you can mount it with the supplied clasps that mount on the side, and you can just screw it right into a panel. But there's a couple of different ways to mount it. And the display unit fits into a standard 30.5 millimeter knockout.
Excellent. The next one is, what is the lowest voltage does it test for?
3 volts.
3 volts.
It won't
Okay.
indicate, it won't indicate, it will not indicate a safe workplace unless we go below 3 volts, and that's stipulated by UL 1436. If you're asking when will the red LEDs come on, we've tested it at very low voltages. Right now that that number escapes me, but what I'll do is I'll test it and I will supply that information.
Okay.
You're saying, you're asking if it works on 120 volts or 69 volts? Yes, it does. I don't know what the low end is. And the low end is going to be less than 50 volts for the red LEDs to come on.
Okay, next one is, what was the threshold for voltage present versus not present?
I think that's the same question, is it not?
Yes.
But what I'll do is I'll test that. The voltage absent is less than 3 volts. The voltage, so you're asking about the difference between the red LEDs on and the green LEDs on. The green LEDs will not come on if the voltage is greater than 3 volts, AC or DC. Now, I think what you're asking me is, will the red LEDs come on if there's 50 volts on the system? I haven't really conducted that test, but I will, and I will publish that information on our website. Or actually, you know what? We're going to answer all these questions to everybody that attended, so we'll put that number on there.
Thank you, Sergio. The next one is, are there plans to integrate auxiliary contacts into the i-AVT to control other equipment?
No, I don't have any plans on doing that right now. I know the Failsafe does do some things like that, but we're not looking at anything like that right now, unless, you know, the market screams out and says they want it. You tell me what the market wants, and I'll consider that my next plan.
Okay. The next one is, are there any safety concerns with opening the panel with the capacitor charge for 15 minutes?
Oh, okay, you're opening the control panel, or you're opening the panel that you're performing work on? I'm assuming the only time you're going to get exposure to the capacitors if you open up the control unit. No, there's no risk of any harmful voltages coming from the capacitor. I think we charge it up to about 5 volts, so there's no harm. 5 volts DC, so there's no harm in touching that. In fact, I've touched it several times, and it hasn't harmed me yet.
Okay. How is the i-Gard better with a capacitor than a battery that you mentioned?
I'm not saying it's better than a battery. I'm stating that it's maintenance free because it does not have a battery. I'm not going to, I'm not here to criticize the Failsafe product. It's a good product, and the only issue I can find with it is that it does have a battery and maintenance is required, however many years it's done. But it is a good product. So the only thing I can say about the i-Gard i-AVT is that it's maintenance free. And there's only 2 products right now that satisfy UL 1436, and that is the Failsafe by Panduit and the i-Gard i-AVT. No other products are tested to UL 1436 as an absence of voltage tester.
Okay, thank you. This question is similar to the previous one. How do we ensure that the capacitor is safely discharged before opening the panel door?
Okay, I think what you're asking me is, does the capacitor apply a voltage onto the conductors while you're working on it? It does not. The only time the absence of voltage tester uses the capacitor is to perform a continuity test and to verify that the meter is working, to verify that the functionality of the i-AVT has been done correctly. No voltage is present on the bus, and this only occurs after you've pressed the test button and after you get the 3 green LEDs. The capacitive voltage does not appear on the bus. It doesn't go on there, and if it does, it doesn't, so you don't have to worry about it. So opening the panel door does not put you at a higher rate of risk because of the capacitor.
Excellent. The next one is, we have a 15 kV application where such a tester would be handy. Can it be made compatible with third-party voltage sensors, between brackets, no VTs, to expand the voltage range to 15 kV?
I've been asked that question many times, and I've been thinking about how to implement an absence of voltage tester on a 15 kV system, or 5, anything greater than 600 volts. Let's put this. But part of 1436 means we have to test phase to phase and phase to ground to establish an electrical safe work condition. I'm not sure right now how I can do that with present technology. We haven't stopped thinking about it, and we have been asked several times on how to do this. But how do you test phase to phase and phase to ground? Because I know some people use capacitive loading to have a flashing light, but that's phase to ground, I guess you would say. How would you measure phase to phase? And until 1436 or 15 NFPA 70E changes for medium voltage, how do you test phase to phase on 15 kV? So yes, we have been giving it some thought, and you're not the first person to ask that question. Every time we put on this presentation, someone will ask that question. And believe me, I wish I had the answer.
The next one is, I thought the unit checked the phase conductor continuity as well as the ground conductor connections.
It does check the phase conductor's continuity. It does that twice. It checks to make sure that both A phase wires are connected to A phase, both B phase wires are connected to B phase, and both C phase wires are connected to C phase. So it does check the continuity of A, B, C, and ground twice.
Okay, let's go to the next one. Can the sensor be affected by induced voltages from nearby energized conductors?
No, part of 1436 means we have to go through a bunch of other IEC tests to ensure that the EMC it does not, EMI and EMC does not provide an erroneous functionality and get 3 green lights. So yes, it was tested with high voltages and high currents nearby, and EMI and EMF and EMC.
Great. The next one is, how long are the green lights remain in the illuminated state?
In order to save power on the capacitor, the green lights only stay on for about 5 seconds. So you press the test button, it undergoes the test, and the green LEDs, if they come on, establishing a safe work condition, they will only stay on for 5 seconds. So once you've established electrical safe work condition, I guess the next step would be to apply your safety grounds or perform your work. But they don't stay on all the time to help conserve the power that's stored in the capacitor.
Thank you. The next one is this unit fail-safe?
In order to, I'm not sure what you mean by fail-safe, but you cannot get 3 green LEDs if something fails. So I guess you would say that it is fail-safe because you can't get a false positive, and SIL3 rating ensures that you'd never get a false positive reading because of any failure in a component or firmware or any outside influence. This is why we had to remove the functionality of establishing or indicating a ground fault present on the system, because there was a 1 in 500 million chance that it might not indicate a red, not even a green LED. It might just not indicate a red LED. So we had to remove that functionality. That's how strict the requirements are for SIL3.
Next question is, how is the i-Gard different, the i-Gard i-AVT different or better than what is available in the market currently?
Well, that's a good question. Because what do you want to compare it to? If you want to compare it to the Panduit Failsafe, which is the only thing you can compare it to, it performs the same function. It verifies the absence of voltage. One is done through a capacitor, the other one is done through a battery. If you want to compare it to a voltage portal or a indicating light that says the voltage is present on the system, you can't compare the two because one is an absence of voltage tester, the other one is a presence of voltage tester. If the light's off and the switch is, you can't really correlate the light being off with the switch being off. Or at least we have shown that in the past, if you rely on the light being off with the voltage being off, that is the wrong thing to do because not many less people are getting hurt by that indication or that false promise that light's off, the voltage must be off. You can't make that correlation. So I could only compare the i-Gard i-AVT to the Panduit Failsafe, and the only thing I can say about the two is one uses a battery, the other one uses a capacitor. They give you the same reliability and they give you the same indication that the voltage is absent and less than 3 volts AC/DC.
Thank you, Sergio. The next one is, what is the life cycle of the supercapacitor? As it is not replaceable as compared to a battery, a life cycle value would be beneficial to compare.
We've got documentation on the battery that it's good for at least 10 years, and we're going to get more indication. What I'll do is I'll get the data sheet and I'll publish it to with this questionnaire, and we're going to answer all these questions again and send them out to everybody. So there's 2 things I owe you. One is what is the minimum voltage that the red lights will come on, and what is the life expectancy of the capacitor.
Okay. Thank you. The next one is there a mean to easily disconnect the i-Gard i-AVT if the circuit being isolated needs to be tested, for instance, via megger or insulation resistance?
No. I was going to say you can pull the fuses out, but you said easily, and removing the fuses does not disconnect the device from the bus. So no, there is no easy way of isolating the i-Gard i-AVT from the circuit if you want to do a megger test.
Okay, then we have a couple of questions related to applications for systems above 600 volts.
Above 600?
Yes.
Well, you know what? We'll address those offline. Are there any other questions? Because I wish I could do something above 600 volts, but
Okay. Okay, no worries. So the next one is, what happens after 15 hours in terms of the supercapacitor?
Well, the supercapacitor will no longer have the voltage capacity to perform another test. So what happens after you press the test button, the 3 green LEDs will come on if you have a safe work condition, and the blue light will come on for a short instance to indicate that there's enough power left over to perform one more test. After 15 hours, it may not have the capacity to perform another test, but it won't indicate 3 green lights if you do press the test button again.
Okay, do we have time for one more question?
I've got all afternoon.
Okay. Okay, let's do this one. If the 2 leads per phase are crimped into a ring terminal and the ring terminal comes loose, does it pass the continuity test?
Yes, it will. It will pass the continuity test because you have continuous connection between the 2 leads. But ideally, you will not place first of all, if you do place 2 of the leads in one ring terminal, you're not following manufacturer's recommended connection installation procedures, because this is what we want to try to avoid. One screw is a point of failure. So we don't want to perform we don't want to have 3 green LEDs come on if there's a single point of failure. And having one screw come off is a single point of failure. So we recommend not using one screw to put 2 wires on.
Okay, I have one more question here and many more. How many times will the supercapacitor allow for testing?
I think we had a slide on there earlier that said about 10 to 15, and at least 10. We've tested as much as 20 tests on one charge.
Okay, thank you, Sergio. I don't know if you want to add any additional comment.
No, thank you very much. Please join us for the next webinar, which will be on transformer protection using surge suppressors. Always a good topic.
Okay, thank you so much, Sergio, for your presentation today. And thanks to all the attendees. We will send a follow-up email, including a link to the webinar recording along with the Q&A document, when we will list all these questions and answers provided by Sergio. Also, we would like to share with you our YouTube channel. Please visit our YouTube channel. We have posted an i-AVT demonstration video over there, so you can go and visit it right now. Thank you all for your time. Have a great day and stay safe.